welcome to the last section in Unit 5. So I made a typo here. This should not be 5.8. We are doing section 5.7, which, like I said, is the last section of Unit 5. So congrats, you made it this far. You only have one more section to get through. I believe in you. You got this. Let's work through this together. So we are going to talk about something called the Pythagorean Theorem. Now, this might sound familiar because you probably have heard this a couple times throughout your life. So this is a very useful thing in geometry. So let's work through this. So recall that in Module 2, Section 2.8 specifically actually, we learned different types of triangles. And we learned how to find the area and perimeter of triangles. In this section, we're going to do more with triangles and learn something called the Pythagorean Theorem. However, prior to doing that, we need to review what a right triangle is because, hint, you can only use this so-called Pythagorean Theorem only with right triangles. You can't use it for any other type of triangle, which is why we're going to review what a right triangle is. So, a right triangle is a triangle that has an angle of 90 degrees specifically. Right triangles often have a box inside them that tells us that the specific angle is 90 degrees. So, with that being said, looking here at this triangle that we have, this box here, this is indicating to us that we have a right triangle because this box is telling us that this angle between these two sides here is 90 degrees. So I'm just going to write 90 degrees here. So with that being said, let's actually talk about what the Pythagorean Theorem even is. So basically, the Pythagorean Theorem, don't let all this fancy math stuff confuse you because it might look scary right now, but we're going to take this entire section to work through all of this. And it won't actually be as bad as we think it is. It looks scary, but I promise it's not as bad as we think it is. So basically, the Pythagorean Theorem is a relationship that tells us that this A and this B here, if we square these two and add them together, they are equal to this one other thing here, this side here that's called C squared. So if we add this A, square it, and we take this B and square it, and we add those two together, that equals the same thing as if we square this side here. So with that being said, let's label some things. So we have some terminology that is going to be very important moving forward, and that is this C, the C length here. This is known as a length called the hypotenuse, which is spelled as follows. So it's Hypotenuse, pronounced hypotenuse. So this is, whenever I say the word hypotenuse, I mean this length C of a triangle. And it just so happens that the hypotenuse is always across from this 90-degree angle that we have here in a right triangle. So in the homework, you'll just be given a right triangle and you'll be asked to find a missing side length. And you won't be told whether or not it's the hypotenuse or if it's one of these lengths here. In order to tell if you have to find the missing length of a hypotenuse, you can realize that, oh, hey, is this directly across from this right angle here? If it is, you're working with the hypotenuse. If it's not, you're not dealing with this so-called hypotenuse. And then these other two lengths here, this A and B, they are referred to as leg, or the legs of the triangle. So B is a leg of the triangle, and A is a leg of the triangle. So let's write that out. So A and B are the legs. And then we also have C, and C is the hypotenuse. And then before we work through some examples, I know this is a lot to take in, but it's not too bad once we get through some examples. We'll get some practice. Let's go through the characteristics of a right triangle. So to go through the characteristics, we have that the hypotenuse is always, I'm going to underline always, across from the right angle. And I already actually mentioned that here when I drew this arrow. So this hypotenuse is always going to be across from this box or this right angle of 90 degrees. And then, according to the Pythagorean Theorem here, with the right triangle, characteristic of it is that the two legs, so we have the two legs, we have this leg A and this leg B, the two legs, or A and B in parentheses, the two legs A and B added together is always longer than the hypotenuse. And then the most important thing that I didn't mention is that right triangles, I mean, I already set it up here in the definition, but right triangles have a 90-degree angle. Okay. And then also, I did not make this photo here that we see. That's all marked up now. So I gave photo credits to the link of the article that made that. So, okay. So below, we're going to now actually find lengths for missing lengths for this triangle. So to do that, we are going to use these formulas here, these fancy formulas. So in this case, in this video, I already have the side lengths labeled for us, but I'm going to talk us through the process as if this C was not here. So remember, we said that C is the hypotenuse of the triangle, and that the hypotenuse is always across from the right angle. So if the C wasn't here, we could find out that this is the hypotenuse because it's directly across from this right angle. So let's say C, if we look above here, look at the formulas, we have a formula for C. That is the square root of a squared plus b squared, which I got from here. So to find what A is and B is, say A and B, we have two legs here. And we can say we can either say A is 4 or 3. It doesn't really matter. But in this case, I'm just going to say A is 3. And since we said A is 3, B has to be 4. So let's plug those numbers in. So we get the square root. So we said A is 3. So we have A squared. So we're going to do 3 squared. And then B is 4. So we're going to add that 4, and then we're going to square it. So whenever you are working with square roots, and you have operations to do inside of them, you can think of a square root as parentheses, an imaginary set of parentheses. So we are going to simplify everything that's under here first before we take the square root. So we're going to do 3 squared, which is 9, and then 4 squared, which is 16. And 9 plus 16 is 25. So we have the square root of 25. And if you've seen from the last section, the square root of 25, we think about it, what do we have to square to get to 5? And that is 5. So here actually, so we can say C equals 5. So for this triangle here, this length, we just solved what this missing length was with this magic formula from the Pythagorean theorem. And that is 5. Actually, I shouldn't say it's not magic, but you will actually learn in a further course that we can actually we derive this formula from this equation here. But that requires algebra work that we haven't gotten to yet. So that's why we're just given the formulas. So looking at our second example, we want to know this length here, this length of B. So I encourage you to pause the video and actually try this one on your own because we worked through an example. And assuming you have given this a try, let's go through it. So we want to know B, so we have to solve for B. If we look above, we have a formula for B. So we have B equals, now looking at the formula, is B equals C squared minus A squared. So C squared minus A squared. So before we plug in numbers, we have to identify what C and A is. So I'm just going to write as blank square root for now. So we know that C is the hypotenuse, right? And as we've seen above, the hypotenuse, or C, is always across from the right angle. So in this case, C is going to be 8. And then A is going to be 6. And then I do want to point out, our hypotenuse is also the longest side length of the triangle. And just using that, you could automatically say, well, 8 is larger than 6, so 8 has to be our hypotenuse, so this length has to be our hypotenuse. That's another way you can do it too. Okay, so we have C, which is 8, so we're going to do 8 squared minus 6 squared. And 8 squared is 64, so we have square root 64, and then minus 6 squared is 36. And if you do 64 minus 36, you will get 28. So this is our length. And as we've seen in the previous section, a square root is a number, but this isn't a perfect square like we've seen in example 1. So this here, square root of 28, is what is known as an exact answer. But to get a better understanding of what that value is, if you evaluate that in your calculator, you will get approximately 5.29. So this length B here, I'm going to give myself room for that, but it's approximately 5.29. Okay. Let's work through a couple more examples before we finish Unit 5. So I encourage you to pause the video and try this on your own. And assuming you have worked through it, let's go through this. So using the formula for A on the previous page, the A is the square root of C squared minus B squared. So actually, one thing I realized is that there isn't this triangle here. So let me write that down here. Or not this triangle, this box here. So this is our right angle. But you actually don't need that to find out what C is. Because as I stated before in the previous example, is that our hypotenuse is always the longest length of the triangle. So since 10 is larger than 4, we could just logic through and say, well, since 10 is the largest number, C, our hypotenuse, is going to be 10. And then since we're solving for A, B is going to be 4. So we get C squared, which is 10 squared, minus 4 squared. So 10 squared is 100. And then 4 squared is 16. 100 minus 16 is 84. So we get the square root of 84, which is not a perfect square, so we're going to get a decimal. And square root of 84, I encourage you to pause the video and actually evaluate the square root of 84 in a calculator to see if you can do that. And if you evaluate in your calculator, you should get approximately 9.17. Now, working through our last two examples, I encourage you to pause the video, try it on your own, actually both of these. Now let's work through this together. So we want to know the side length B, which we know is the square root of something. So we know that from the above, we have C squared minus A squared. And looking at this triangle, we know since 6 is our largest value, that is going to be C. And since we're solving for B, our missing variable is A. So A is going to be 3 from this other side length. So we have C squared, which is 6 squared, and then minus 3 squared. 6 squared is 36, and 3 squared is 9. So we have 36 minus 9. 36 minus 9 is 27. I don't know why I wrote that square root so large. And the square root again, yet again, is not a perfect square, which usually does happen. Most of the time, you don't get a perfect square. So the square root of 27 is approximately 5.20. Now, looking through our very last example of Module 5, we have this triangle here. Now, it is important to realize that we have a right angle here and a right angle here. And this side length here is 5, and this side length here is also 5. And this length here is 4, and this length here is also 4. So what we really have going on here, I'm going to draw out two separate triangles. And we know that this is 5, that this is 5, and this is 4, and this is 4, and we're solving for B. And one thing you'll notice is that you're like, wait a minute, both of these are the same exact triangles. And they are. They are. They're just two of the same exact triangles, just smushed together. That's all it is. So all we're going to do here is evaluate for B. And as we've seen above, B equals the square root of C squared minus A squared. Which, so we're going to write that up. C squared minus A squared. And since 5 is our longest length, C is going to be 5. And then A is going to be 4. So C squared is 5 squared. And then minus A squared, which is 4 squared. 5 squared is 25. 4 squared is 16. 25 minus 16 is the square root of 9. And square root of 9 is actually a perfect square because 3 squared equals 9. So therefore, square root of 9 equals 3. So, grand finale of the last example of Module 5. B equals 3. Congratulations, you have made it through one of the hardest units in this class.